Welcome to this lecture. In this lecture, we are going to solve a linear programming problem by using graphical method. The problem is solve the LPP by graphically maximum of z equal to 3x1 plus 2x2 subject to the constraints x1 minus x2 which is less than or equal to 1 and x1 plus x2 greater than or equal to 3 and x1 comma x2 greater than or equal to 0 is a non-negative restriction. Okay, in order to solve this equation, start the procedure to solve the equations. We know that step number 1 is let us identify the points on the equation number 1 and 2, which is here. Consider x1 minus x2, which is equal to 1, the equation number 1. Then the point on the line, if x1 equal to 0, then 1 implies minus x2 equal to 1, x2 equal to minus 1, therefore 0 comma minus 1. If x2 equal to 0, then 1 implies x1 equal to 1. It is 1 comma 0. Let us consider the second line. Let us identify 2 points on the line. If x1 equal to 0, then x2 equal to 3. If x2 equal to 0, then 2 implies x1 equal to 3. Therefore, this related to this equation number 2, 0 comma 3 is a point and 3 comma 0 is another point on the line. Let us draw the graph. Consider the graph sheet like here. Let us represent equation number 1 in graph. Point number 1, 0 comma minus 1, 0 comma minus 1 take place 0 comma minus 1 the point, and 1 comma 0 another point. Let us draw a line. This is equation number 1 here, which is given in less than or equal to. Okay, so therefore we need to cover all the lines which covers 0. Here 0. So this region is covered by equation number 1. Since it is less than or equal to, so it has to be covered 0, 0. Okay, next line, x1 plus x2 greater than or equal to 3. Okay, on the line 0, 3 is one point, 3, 0 is another point. Let us connect it by okay, it is also it is greater than or equal to, is greater than or equal to, so greater than or equal to is equation number 2. So we need to cover the region so now we may see the yellow lines are the region covered by equation number 2. Let us identify the common region. Okay, here green shaded lines curves, right? Actually not curve, it is a region region bounded by this green above. All these all are feasible, but unfortunately we cannot able to see its maximum point. It is an unbounded region. Our motivation is finding the maximum value of this problem. Since the region is unbounded, therefore it has no optimum solution. Since the region is unbounded, so this problem have no, it has solution but it has no optimum solution. So we claim that in generally an LPP have a feasible solution, but it may does not have the optimum solution. It's a very important problem also. That's all from this lecture. Thank you.